In this ACT review video, we're going to take a look at the geometric formulas for area. We're going to go through many of the common formulas you might see and then look at a particular situation that's pretty common as far as examples go. So let's start with just the area of a rectangle. Remember, a rectangle is just a different type of quadrilateral, and the area is just the length times the width, okay? And so it's important to remember too that area is in square units. So I don't have any units listed here, but it might be feet squared or meters squared or inches squared, or we might just say square units. The formula for a triangle. The area of a triangle is 1/2 base times height. So you might write it like this, 1/2 base times height. Now, in my picture over here, I have the height on the outside, but what you might also have to do is drop a perpendicular like this. The height has to be perpendicular. So you could also see the height like that. And you could see you'd form a right triangle. So remember, Pythagorean theorem might help you as well. So they like to make combo problems. So they might have Pythagorean theorem and area mixed into one situation. The circle, the area of a circle is pi r squared, pi times the radius squared. I've got it in words and I'm writing for you in symbols. Make sure you read the directions in the problem. They might want you to leave it in terms of pi, or they might want you to use 3.14 for pi. Just make sure you read and do what they ask you to do. Parallelogram, okay, just kind of looks like a slanted rectangle, and the area of a parallelogram is length times height. So area is length times the height, but that is not the height. That side is not the height. The height is from top to bottom. I've got it shown right here on the outside, but much like the triangle earlier, you may have to drop your perpendicular right there, and that's another way to show the height in a parallelogram. So remember, height is perpendicular with the base or the length. All right, trapezoid. We got a lot going on right here. The bases in a trapezoid are parallel. Okay, remember that from the quadrilateral video. And then right there through the middle of the legs, that's the median. And then the height, of course, is from the very top to the bottom. There's two formulas for this. You can say the area is the sum of the bases divided by 2 times the height. So we could write that as area is 1/2 base 1 plus base 2 times the height, words and symbols. Or you can just say area is equal to the median times the height, because the median is half the sum of the bases. I think this first one's probably the more common formula. Rhombus. Okay, so the rhombus is, you can find the area by finding 1/2 the length of the diagonals multiplied. So we need to get diagonal AC and multiply it by diagonal BD and take half. So that, in this case, half of AC times BD. We don't really have any words for that, but just maybe say those are the diagonals, the product of the diagonals. All right, no matter what the shape is, though, one of the more common problems you may see is this area of a shaded region. And here we just have two circles. What's the area of the shaded region in the figure below in pi form? Okay, so we're going to have two things going on here. We want our answer in terms of pi, and that just means we're not using the calculator. We're not using 3.14. We're just using the symbol. So area of a shaded region is very common. So we see two circles here, and we need to find the area of both of them. So we're going to find the area of this outside circle. It's kind of like a donut. Then we're going to go find the area of the inside circle. And then we're going to have to subtract the two areas. That just gives me that border. So this has actually 3 steps. We're going to first find the area of the big circle. Write your formula down. Area is equal to pi r squared. And the big circle has the radius of 6. So area is equal to pi times 6 squared. And 6 squared is 36. So this is 36 pi. They didn't give us any units, so I'm not going to worry about it till the end. Then I also need to find the area of the smaller shape, in this case, the small circle. Again, this could be done with all sorts of figures and different area formulas. And the smaller circle has an area of, a radius of 4. So area is equal to pi times the radius 4 squared. Area is equal to 16 pi. And then our third and final step is going to be to subtract the two areas. So 36 pi minus 16 pi gives us an area of the shaded region of 20 pi. And I'm just going to write square units. It's multiple choice, so you won't really have to worry too much about that on the ACT. But I just want to make sure you understand that area is in square units.